Math 151, let's do a problem on optimization. 1200 centimeters squared of material is available to make a box with square base and no top. Find the largest possible volume of the box. So let's first of all do a drawing, a picture. So here's a base, square base. So let's say these are all 90 degrees. And let's call this each side B for base. And of course, this is the height of the box. Let's call it H. And this box has no top. So the material that we're going to be using is only for the base and 4 sides. So I can claim, based on that fact, I can claim that 1200, which is all of the material that I have to in my position, equals the area of the base, which is B squared, plus 4 sides for 4 times height times base, or base times height. And so here I'm going to go ahead and solve for H. Solve for H. That gives me 4HB equals 1200 minus B to the second, and H equals 1200 minus B to the second over 4B. Okay. Let me go ahead and go to the next page and continue. I know that the volume of this box, the volume equals the area of the base, B squared times height. So V equals B squared, and we already solved in previous page for height, and we have 1200 minus B squared over 4B. Let's simplify this just a baby step. I have V equals B squared. So 1200 over B, I know that I can go ahead and cancel, since this cancels with this B, since this 4B is the denominator for both of them. And let me get rid of this squared. So 1200 over 4 gives me 300. And now I have minus 1/4 B to the second. Okay. So now volume equals 300B minus 1/4 B cubed. So now I'm going to go ahead and take the derivative of this, going to the next page. So V prime, or I can say V prime of B equals 300 minus 3/4 B to the second. And I'm going to set the derivative equal to 0. So I get 300 equals 3/4 of B to the second. Now, multiplying both sides of this equation by 4/3, so multiply both sides by 4/3. So this gives me B squared equals, that gives me 100 times, so 400. And B equals to plus and minus 20. And I'm going to toss the minus because I don't have it with geometry, I don't have negative base. So B equals 20. So now, starting from 0 and 20 is my critical point. If I test a number between 0 and 20, let's say 1, and I plug that in V prime, I get a positive result, so all the way in here. And after 20, let's say if I try a number, let's say 25, 30, and plug it in let's say 30 squared is going to be 900. Oh, certainly I get the negative numbers in here. So notice that this looks like, I mean, the tangent lines are going up before 20. It's 0 at 20, since we found out, we took the derivative, say equal to 0, and they're going down after 20. So I do have a maximum at 20. So let me go to the next page. So we have a maximum at h equals 20. Okay. And when we solve for h, we said that we have h equals to 1200 minus b squared over 4 times b. Okay. And so this gives me h equals 1200 minus 20 squared over 4 times 20. That gives me 1200 minus 400 divided by 80. So that gives me 800 divided by 80, and that gives me 10. Okay. So H equals to 10. So the largest volume my handwriting is getting bad. Largest volume is going to be, we know that volume equals b squared times h, so v equals 20 squared times 10, and that's 400 times 10, so 4,000. And remember that the unit was centimeter, and since this is volume, cubic centimeter. So 4,000 cubic centimeter is the largest volume we can expect to have uh, with 1,200 uh, square centimeter of the material available to us. Okay, thanks. I'll do another one, another optimization problem showing you how to find how we minimize something.